we have a car traveling at a constant speed of 28 meters per second, which timesing by 3.6 gives about 100 kilometers per hour. So they're out, on the open road somewhere. Now they approach a corner, so they're going a bit fast for the corner, and so they apply the brakes to decelerate. They decelerate at a constant rate of 4 meters per second squared until it reaches the corner with a speed of closer to 40 kilometers per hour. Use calculus to find how far the car was from the corner. So we're looking for a distance when they first applied the brakes. Justify your answer. Alright, so kinematics problem. We are given acceleration as 4 meters per second squared. And if they are decelerating, we should consider that as a negative acceleration. Right? If you take it as positive, it's fine, as long as you take what was positive as negative. But to keep it simple, decelerating means a negative acceleration. And so just a reminder, our kinematics relationships, distance, the rate of change of distance is velocity. The rate of change, or speed, the rate of change of speed is acceleration. Inversely, the antiderivative of acceleration is velocity, and the antiderivative of speed or velocity is distance. And I use the word speed and velocity, or distance and displacement, interchangeably here because they're traveling on a straight road, which is in one direction. So we don't need to be too concerned about the vectors, other than the fact that we have a negative acceleration. Okay, so that's the problem. We are looking for a distance. Right, we are looking for distance. We are given acceleration. And so to find the distance, we will need to find the speed function, v, by integrating, and then we will need to integrate once more to find the distance. Right, so there's two integrations happening here. So firstly, to find the speed equation, we anti-differentiate acceleration, which will become negative 4t plus c. Right, we have that integration constant, because if we differentiated, any constant would become 0. But going the other way, we're not too sure what 0 becomes. Alright, so how do we work out this c value, this integration constant? It is actually just the initial speed. Right when they start applying the brakes, they are traveling at 28 meters per second when time is 0. So if we substitute in 0 for time and 28 for speed, we will see that c will equal 28. So therefore our speed equation is minus 4t plus the initial speed, 28 meters per second. Okay, so we've found our speed equation. Now we are looking for the distance, so we will need the distance equation. So to get that, we will anti-differentiate again. So the antiderivative of minus 4t, add 1 to the power, divide by the new power, plus 28t plus c. Alright, so just simplifying that, minus 4t over 2 becomes minus 2. And what about c? So again, think of this as the initial distance measured from when they start the stopwatch. So from the problem, they start applying the brake at time 0, and so little diagram, beautiful car, here's you, right? You apply the brakes at this line right here. So that's when we start measuring time. It is also when we start measuring the distance. So the initial distance is 0, and then the corner is somewhere over here. So our value for C in this case will be 0. Alrighty, so now we found the equation for distance, but now we need to find the distance the car was from the corner, right? So what is this distance here? So looking at our distance equation, it takes an input of time to give an output of distance. So we need to know the time it takes for the car to reach the corner. Because if we have the time, we can then work out the distance. Just rereading the question, we know that the car reaches the corner with a speed of 10 meters per second. So using our speed equation, with speed equaling 10, we can work out the time that the car is at the corner. So finding time to corner. So again, using a speed equation, they are traveling at 10 meters per second. And we know that equals minus 40 plus 28. So subtracting 28, both sides. Dividing both sides by -4. We get 18 over 4, or 4.5 seconds. Alright, so the time it takes from when they brake to the corner is 4.5 seconds. Now we can work out the distance, right, using our distance equation. So finding distance to corner. So the distance at 4.5 seconds is minus 2 times 4.5 squared plus 28 times 4.5, which times 4. So careful when we, well, are squaring, let's just use our brackets. It's more important when we have a negative value that we're squaring, but 28 times 4.5, which gives 85.5 meters. And that's a positive value, which we expected, because we defined the positive direction to the right. Right, it was decelerating, so negative goes to the left. Cool, and that's that. So let's go over this question one more time. So kinematics problem, we were given acceleration. So our first step was actually to write that as an equation, just to help us. We then realized we were looking for distance, so we needed to anti-differentiate twice. In both instances, we had to solve for that integration constant c. The second one, when finding distance, it wasn't as obvious. So this diagram helped us just realize that when we start the timer, their distance from that position is 0 meters. Right, that is a very common assumption. However, to find distance, we needed the time it took to get to the corner, so we used the speed equation to find time. And so finding the speed equation was actually the achieved part, because we anti-differentiated. Finding the time it reaches to the corner and finding the distance equation was our merit part. And then correctly finding the distance was the excellence part. Alright, I guess moral of the story is if you're approaching a corner, make sure you slow down in time. Alright, safe driving.